5.4 part 2. And what we're doing today is called synthetic division. This is kind of the second method for dividing polynomial functions. Synthetic division. What does the word synthetic make you think of? Fake. Man-made.
Wait, what did you say? She said oil. Like a cheat way.
Like a cheat way, right? Synthetic, like a false or fake, but kind of works the same way, right? That's exactly what we're doing. I like that she said like a cheat way. It's a shortcut. Synthetic would be a man-made operation, whereas long division is actually like naturally occurring in the arithmetic world, right? We understand how that process works. That one was yesterday. Today's a shortcut, okay? Always teach the long method before the shortcut. Otherwise, they don't want to learn the long way. Here comes synthetic division. So our job here is to divide the polynomial 2x cubed minus 3x squared plus 4x plus 5 by x plus 2. So we're dividing this long polynomial function by the linear factor x plus 2. Okay? Synthetic division is a shortcut. It works every time. Sometimes you have to manipulate the problem to make it work. And in that case, I think it would be easier to just do long division. Okay? Yesterday, y'all did the long division. You didn't hate it. You thought it was cake, right? So in the event that your problem's not set up to use synthetic division, I think it would be easier to just do long division instead of trying to manipulate this problem so that you could use the shortcut. It would be better just to do the long way first, okay? So synthetic division works best when the number in front of the factor that you're trying to divide by is 1. Sorry. The coefficient of your factor needs to be 1. If it's not, you should do long division. Okay? This is a forward on all of your homework problems. I already picked the ones that are good for synthetic division, so you don't have to worry about it. I picked the right ones for you. Okay, so here's the process. You take this linear factor, x plus 2, and that needs to be set equal to 0, so that you have a number, x equals -2. You with me? So that number, -2, goes in the box. Little bitty box. Kind of only have the right side and the bottom side of the box. Next, we're going to write down all of the polynomial coefficients. So we're going to write a 2 and a -3 and a 4 and a 5. So 2, -3, +4, and 5. And we don't write any of the variables, just the coefficients here. Okay? Yeah. She said, do we need to write it that far apart? Yeah. Okay. The next thing that you should consider is make sure you have a number representing every place from the highest degree to the constant. So what's my highest degree here? 3. So I need something for x cubed, x squared, x, and the constant. If one of these coefficients was missing, like if it didn't have the 4x piece right here, you would have to put a 0 in the placeholder. We'll see some like that today. Okay, so if you don't see, like if this term wasn't there, you would have to put a 0 where the 4 is. Does that make sense? Okay, so for right now, we have the 4x, so we put the 4, it's good. Okay, so here's how this works. You're going to drop the first number down to the bottom row. We're working with 3 rows here. Row 1 is what you just wrote. Row 2 is in the middle. Row 3 is on the bottom. So we're going to drop the first number to the bottom. Then we multiply the 2 times the -2 in the box. -4. You write the -4 under the next number. Now we add the negative 3 and the negative 4. So the process is going to be the same every time. We're going to multiply and add, multiply and add, multiply and add. Okay? So negative 3 plus negative 4 makes negative 7. Now we're going to multiply the negative 7 by the negative 2. 14. Add 4 and 14, what you get? 18. 18 times negative 2. Negative 36. You sit way back there. Nobody picked that up. That's fine. Negative 36 plus 5. Negative 31. Negative 31. Whoa. Y'all going to have to talk quieter so YouTube doesn't know what we're actually saying. Okay, so this is our answer. Actually, the 2 and the negative 7 and the 18 and the negative 31. This is how this works. If I started out with x cubed, when I divide by an x term, everything drops down 1 degree. Do you remember yesterday we had 2x cubed divided by x and we got 2x squared? Right? So this is going to be 2x squared minus 7x plus 18 with a remainder of negative 31. Look back at your first problem that we worked yesterday. You remember these numbers? This was the answer we got yesterday. 2x squared minus 7x plus 18. Remainder negative 31. Cool? So it's a shortcut. Pretty neat. Another way you could have written this was 2x squared minus 7x plus 18 and negative 31 over x plus 2. Remember, that's another representation of the same information. What do you think? You want to try another one? It doesn't matter if you want to or not. We're doing it. Cool. All right, so here's example 3. It says, divide 5x squared minus 3x minus 36 by x minus 3. So what goes in the box? 3. 3 in the little box. And then my coefficients are 5, negative 3, negative 36. And the first thing we're going to do with the 5 is drop it straight down. And then we do is negative 3 plus 15. 12 by 3. 36. Negative 36 and positive 36. That's my favorite. A remainder of 0 indicates that we've found factors. Okay, let's think. Is 12 a factor of 50? No, because if you divide 50 by 12, you can get close. You get 48, right? 12 times 4 is 48, but there's a remainder of 2. So 12 is not a factor of 50. If it was a factor of 50, you could divide by it and have no remainder. You see what I'm saying? Is 7 a factor of 35? Yes, because 35 divided by 7 is 5, no remainder. You see? So in this problem, we just divided a quadratic polynomial by x minus 3, and we got no remainder. What that means is that this answer right here, what is this, by the way? 5 what?
5x
Plus 12 is a factor of the polynomial. So if we know x minus 3 is a factor, and when we divided by it, we got no remainder, then 5 plus 3 is the factor. These are the two factors of that polynomial. You remember that when we're factoring, we're dividing? So this is another way of finding out what your factors are. What can you do once you find your factors? What are they good for? What do they show you on the graph? X-intercepts. X-intercepts. Yeah. What you think? Wonderful? Wonderful. I love it. All right, let's do another one. Yeah. Yeah, we got a bunch of examples, but this is all we're learning. They're all the same. Is it okay with you? Okay, good.
Can I use the restroom?
Yeah, go fast.
No, I asked first.
Oh, she did ask first. Are you gonna fight her? What is this?
Yeah.
Whoa. She was pretty serious about it. Okay, we're going to divide 4x cubed plus 10x squared minus 6x minus 20 by x plus 2. So what goes in the box? Negative 2. Good, Bryson. And whoever else that was. Yeah, I knew you were going to have hurt feelings. Okay, a 4 and a 10 and a negative 6 and a negative 20. Agree? Are y'all already doing this without me? Okay, good. So I get 4x squared plus 2x minus 10 with no remainder, right? So if I had this term, which we just came up with, and the other term, x plus 2, I know one of my x-intercepts on this particular polynomial is at x equals negative 2. Where are the other ones? What could you do next? Well, we said that these are the factors with no remainder, right? So these are the locations of our x-intercepts, and one of them happens to be at x equals negative 2. How could you find the other ones? Set the other piece equal to 0. This piece we just got, 4x squared plus 2x minus 10. We could factor that guy. Y'all seeing what I'm saying? You see it? I would pull a 2 out before I tried to factor that. But then, and that's what we're going to be doing next week when we come back, we're going to learn applications of synthetic division. So not only how to do it, but what is it good for? Because by then, you would have these zeros and the x plus 2 one, and you could really start to form a graph based on this information. Cool? Yeah, okay. Easy peasy, lemon squeezy. We're mowing this down today, y'all. That was a good job. Did I mess you up? Did I mess you up? Did I mess you up? Go back to sleep. Aren't we all? Okay, so this is a 4th degree polynomial. What goes in the box? 1. And then? Uh-huh. And then? And then? Okay, here's where you're going to have trouble. So right here, between the x squared term and the constant, there should be something in the x position. Every single term should be represented, right, from the highest degree to the constant. And in this case, they didn't put anything there, which is fine, except when you write in the coefficients, you've got to acknowledge that there's nothing there. I'm sorry. I should have caught you. I tried to set you up for failure, and my bad. I did let you fail. But maybe just now in the practice so that you don't fail later, you know? Yeah. Okay. Now it's the same as it was. I'm sorry. Should I redo it? Do y'all need me to redo it? Or did y'all get it?
No, I've got
You got it? Okay. Sorry. Sometimes with the synthetic division stuff, I'm just kind of going crazy. How could you check your answers? You could FOIL it. You could multiply your answer, 9x cubed plus x squared plus 8x plus 8 by x minus 1. And at the end, if you'll add 2, you should get back to the polynomial that you started with.
And I can just put R2, right?
You could put R2. Well, that was so nice.
Oh.
Because I don't like R in the middle of my problem. Like, I want it to be something that I could work with algebraically.
Can you not do the equals? Oh, yeah. Like how we did.
How we did yesterday? Yeah, you sure could. You could say negative 9x to the 4th plus 10a. It is long. Like this? This is what you're talking about?
Equals, just x minus 9x cubed
Plus blah, 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 blah. It works.
Oh.
Yeah, that's correct. The plus 2 on the end is what makes it work. So is x minus 1 a factor?
No, just
Because there's a remainder of 2. Perfect. Good. Good, good, good. Y'all got 2 more problems in you? That's all we have left.
Okay.
2 problems.
Wait, the 0 was for the x that wasn't there, right?
Correct. Look at you.
It's so fun.
2 more and that's it. All right, so example 6 starts bringing in some word problems, some application. I know. Okay, but these are the only words. Are you ready for this? It says volume of a rectangular solid. What's another name for a rectangular solid? Prism. Yes, this is like a Kleenex box, right? Rectangular prism. The volume of the rectangular solid is given by 3x to the 4th minus 3x cubed minus 33x squared plus 54x. I think that's a crazy volume, but who am I to say? The length of said prism is 3x. And the width of this weird prism is x minus 2. Find the height. Bruh. So what do we know about volume of the prism? Well, think back to 8th grade. How do I find the volume of a rectangular prism? Length times width times height. Good. Base times width times height. Okay. So volume of this prism is length times width times height. Are y'all following that? Okay. So let's set our polynomial, this volume, 3x to the 4th minus 3x cubed minus 33x squared plus 54x. Set that equal to length, 3x, times width, x minus 2, times height, h. Length times width times height. Yeah? Now we need to solve for height. So we're reversing it. We're going to undo it. To solve for the height, what's the first thing we could do? Leave the h alone. I think we want to divide by 3x. Divide by the length. We're trying to isolate h. We're trying to get h by itself. So everything over here that's with h, we're going to have to divide off. I would divide by the length first. This was length and width and height. I think we should get rid of the length first.
Do we still put the x at 54?
Uh-huh. Yes. So if we divide by 3x on the right side, now we're down to x minus 2 and h. On the left side, we're going to divide every single piece of that by the 3x. So do them all, one at a time. 3x to the 4th divided by 3x. X cubed Negative 3x cubed divided by 3x. Negative x squared. Negative 33x squared divided by 3x. 54x divided by 3x. 18. Excellent job. Equals x minus 2 h. Now you seeing where we're headed with this? Kind of feel like the train has its chugga, 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 chugga. Here we go. What's next? How are we going to get h by itself? Divide by the width, x minus 2. I know. Well, we can't cancel. Hold on. Because it's an x minus 2. It's a binomial. So earlier we could divide every piece by the 3x, and that was fine. But I can't divide by 2 terms at once. No. What did we just learn how to do? What was this whole lesson about? Synthetic division. We have a polynomial divided by x minus 2. This is this is why we learned this. Right? So what goes in the box? A 2. What goes outside of the box? 1. And? See? It's useful. Drop the 1 all the way down. So what's the height? X squared. Perfect. That is the height of the rectangular prism. You know it was x squared because if you look right back up here, the term that you had before you divided was x cubed. And your answer is going to drop 1 degree from that. Okay? So I'm going to give you a try it. And that's the last problem for today. The try it goes with this particular example. Cool? Okay. So for the try it, they give you the area of a rectangle. Area of the rectangle. And the area for this rectangle is 3x cubed plus 14x squared minus 23x plus 6. And the width of said rectangle is x plus 6. What is the length? So how do you find the length? Right? So area is length times width. If we'll divide by the width on both sides, we'll get the length. So we're going to take our area function, which is this cubic polynomial, and we're going to divide it by this linear function, the width.
Is that 14?
Yes.
Yeah, 14x squared. So you do it and I'll do it, and we'll see if we get the right answers or the same answers. Sorry. How could you check it? Multiply your length times the width. and C. And that just is distribution. Okay, it's not FOIL because you've got 2 terms and 3 terms, but it's just distribution. Any questions on this today? Did we do okay? Okay. So you've got, I think there were 8 problems for the weekend. 8 problems. I picked nice ones.
And number 19 is the same as 14.
Same problem?
Yeah.
Well, how did I not realize that? $19 and $14 are exact same problem?
Yeah.
That's dumb. Well, how did I get 2 different answers? That's scary. Huh. Well, y'all get a bonus. I even checked it. I got them both right for myself. I checked them both and I got the wrong answers. That's awesome. Go me. On the homework, 19 and 14 are the same. So I would say only do them once. Or do them twice and get different answers both times, which is unbelievable. Okay, cool. Thanks and giggle.